15 million years ago, South America was an island. For roughly 60 million years, it had been cut off from the rest of the world. No land bridges, no lions, no wolves, no bears, no way for the great predators evolving elsewhere to reach its shores. So evolution built its own. On the grasslands of Patagonia, a bird nearly 3 meters tall hunted across the open plains. It could not fly. It did not need to. Its skull was the size of a horse's head. Its hooked beak could puncture bone, and it could sprint across open ground at nearly 50 kilometers per hour. For millions of years, it stood at the top of the food chain, but it was not alone. Sharing this isolated continent was a crocodile that ran on long legs and hunted on land. There was also a saber-toothed predator that looked eerily familiar to later cats, despite not being a cat at all. Three different predator dynasties, three different solutions to the same problem, all evolving in complete isolation from the rest of the world. The largest terror bird skull ever discovered measured 71 centimeters long. The largest of these land crocodiles reached 6 meters in length. And when the isolation finally ended 2.8 million years ago, the world they had ruled for tens of millions of years began to disappear. In this story, we're exploring one of the strangest evolutionary experiments Earth has ever run. If this is your kind of thing, hit like and subscribe. It costs nothing and it keeps this channel going. And drop a comment below. Are you winding down for the evening, or is your day just getting started? Now, let's travel back to a continent that spent 60 million years building monsters the rest of the world never had. A map of the modern world gives little hint that South America once spent an immense stretch of time apart from nearly everything else. Its mountains, forests, and grasslands seem naturally connected to the broader story of Earth. Yet for tens of millions of years, the continent drifted through a chapter of history that belonged almost entirely to itself. The separation began during the breakup of Gondwana, the southern supercontinent that once joined South America, Africa, Antarctica, Australia, and India. As deep forces within the planet slowly reshaped the crust, South America pulled away from Africa and opened a widening ocean between them. Year after year, century after century, the distance grew. Shorelines that had once fit together became strangers divided by water. By the time the age of dinosaurs ended 66 million years ago, South America had already become a world apart. Oceans surrounded it on every side. No land route linked it to North America. No pathway connected it to Africa, Europe, or Asia. Across the globe, mammals were diversifying into new forms, spreading into fresh habitats, and competing across interconnected continents. South America watched this transformation from across the water. Paleontologist George Gaylord Simpson later described this period with a phrase that endured: splendid isolation. The words captured more than geography. They described a continent operating according to its own evolutionary rules, separated from many of the influences shaping life elsewhere. The isolation created a setting unlike almost any other in the history of mammals. At the place where Panama stands today, there was no narrow bridge of land. Atlantic and Pacific waters flowed through an open seaway, mixing between the oceans and maintaining the barrier that kept South America detached from its northern neighbor. Marine currents passed through the gap, while terrestrial animals remained confined to their respective continents. This separation carried enormous consequences. Across North America, Europe, Africa, and Asia, placental carnivores were becoming increasingly successful. Early relatives of future wolves, bears, cats, and many other predators expanded into ecological opportunities left behind after the age of dinosaurs. None of them could reach South America. The sea prevented every advance. That absence shaped everything that followed. Predator roles still existed. Herbivores still needed to be hunted. Ecosystems still required balance. Yet the animals filling those positions would emerge from local lineages already present on the continent. Evolution worked with the materials available, producing solutions found nowhere else on Earth. The island itself was enormous. Rainforests stretched across humid regions, rivers crossed broad lowlands, coastal environments bordered long shorelines. Expanding grasslands appeared in some eras, while forest dominated others. It was an entire continent functioning as a self contained evolutionary arena, large enough to support extraordinary diversity and isolated enough to steer that diversity along uncommon paths. Through the Paleocene and Eocene epochs, the separation endured. Millions of years accumulated, generations passed beyond counting. Lineages adapted, diversified, and experimented within boundaries set by geography. The seal remained intact until roughly 2.8 million years ago, when the Isthmus of Panama finally closed and connected the continents. By then, South America had already spent around 60 million years creating a biological world entirely its own. The turning point arrived in a single geological instant. Across Earth, ecosystems that had been shaped by non avian dinosaurs for more than 160 million years came apart. Forests, floodplains, and coastal regions entered a period of disruption that echoed through every branch of life. On South America's isolated landmass, the effects reached far beyond the disappearance of familiar giants. Before the impact, large predatory dinosaurs occupied the highest hunting roles. Their presence influenced where animals fed, where they traveled, and how entire communities were arranged. When those predators vanished, an immense ecological space opened. The top positions in the food web stood vacant. No established successor waited to inherit them. Elsewhere, that vacancy would eventually be filled by placental mammals. Across connected continents, mammalian groups diversified rapidly and expanded into newly available opportunities. Future relatives of wolves, bears, and cats began journeys that would shape ecosystems for tens of millions of years. South America existed under different circumstances. Water still separated it from every other major landmass. The continent could not draw from the growing pool of northern predators. Immigration on a meaningful scale was impossible. Whatever came next would have to emerge from the survivors already present. Those survivors formed a modest caste compared with the world that had been lost. Small metatherians, relatives of later marsupials, persisted through the upheaval. Early xenothrans, distant ancestors of armadillos and sloths, continued their lineage. Crocodile relatives endured in waterways and along shorelines. Birds remained among the most adaptable inhabitants of the recovering landscapes. From these groups came an extraordinary evolutionary response. Ecologists refer to such events as adaptive radiations, periods when organisms diversify rapidly as ecological opportunities become available. South America offered opportunities on a continental scale. Hunting niches, scavenging niches, browsing niches, and grazing niches all awaited occupation. Generation followed generation. Body plans shifted, diets specialized, limbs lengthened or strengthened, teeth changed shape. Some lineages experimented with lifestyles that had never existed within their ancestry before. Evolution acted without any blueprint, guided only by survival and reproduction across immense spans of time. The absence of outside competition gave these experiments unusual freedom. In many regions of the world, newly evolving predators had to contend with competitors arriving from neighboring continents. South American species faced a different challenge. Their competitors were largely fellow island inhabitants, each adapting from the same limited pool of survivors left behind after the extinction. This circumstance produced outcomes that would have seemed unlikely at the moment the asteroid struck. Birds moved toward predatory dominance. Metatherian hunters diversified into forms that echoed creatures evolving elsewhere while remaining unrelated to them. Crocodile relatives explored lifestyles far removed from those of their modern descendants. Entire predator communities emerged from foundations that differed dramatically from those found across the rest of the planet. The significance of this transformation reaches beyond the animals themselves. Two continents can confront the same ecological problem and arrive at very different answers. South America demonstrates this principle with unusual clarity. The island's future rulers did not descend from the ancestors of lions, wolves, or bears. They arose from local survivors carrying their own evolutionary histories. Within the empty spaces left by the dinosaurs, a new world began assembling itself, piece by piece, from materials found nowhere else. Among the many survivors navigating the reshaped world after the Cretaceous Paleogene extinction, a small group of birds began traveling an evolutionary path unlike any other. Their earliest ancestors would have looked unremarkable beside the giants that had recently vanished. They possessed wings, light frames, and the familiar characteristics associated with avian life. Nothing about them hinted that their descendants would someday become the dominant hunters of an entire continent. The fossil record places the first members of the Forest-Racidae around 62 million years ago, only 4 million years after the disappearance of the non-avian dinosaurs. In geological terms, this was scarcely any time at all. Ecosystems were still reorganizing. New opportunities remained open. Across South America, predator niches that had once belonged to reptiles of enormous size still lacked permanent occupants. Birds proved unexpectedly capable of answering that vacancy. Their lineage traces back to flying ancestors related to the branch that would eventually produce the modern Seriema. Flight had served those early birds well. Wings offered mobility, access to food, and escape from danger. Across much of the world, those advantages remained invaluable. South America's isolated conditions encouraged a different calculation. Large mammalian predators were absent. There were no packs of placental hunters racing across the landscape. No cat-like stalkers waited in ambush. The pressure to remain airborne weakened. Natural selection began favoring individuals that invested energy elsewhere. Bodies became larger, legs lengthened, running ability improved. Generation after generation, flight grew less important. As wings lost their central role, the birds themselves changed shape. Their center of gravity shifted. Muscles adapted to terrestrial movement. Skeletons became increasingly suited for life on the ground. The transition unfolded gradually across millions of years, each step preserving whatever traits proved useful in the environments of the time. The process produced something unusual in the history of birds. Most avian lineages retained flight even when they grew large. The ancestors of the terror birds moved in the opposite direction. They exchanged the sky for speed, stature, and predatory efficiency. The choice was written into their anatomy long before the largest forms appeared. Diversity followed. New species spread into different habitats and experimented with different hunting strategies. Some remained relatively modest in size. Others pushed toward greater height and mass. The family expanded across South America while maintaining its place among the continent's leading predators. No outside challenger arrived to interrupt the process. Climate and landscape continued evolving around them. Forests shifted, river systems changed course. By roughly 27 million years ago, expanding grasslands began transforming large portions of the continent. Open country favored animals, capable of covering ground efficiently, spotting movement at a distance, and closing space with speed. The terror birds entered this new setting already prepared. Their long legs, upright posture, and terrestrial lifestyle fit naturally into the spreading grasslands. Conditions that challenged some lineages provided opportunity for theirs. Larger species appeared. Predatory specialization deepened. Their presence became woven into the ecological fabric of the continent. For more than 60 million years, the lineage endured near the summit of South America's food webs, a span so extensive that entire groups of mammals elsewhere rose, diversified, and disappeared, while the terror birds continued their long ascent across the island world. Bones reveal intentions. Long after muscles, feathers, and skin have vanished, the architecture of a predator remains preserved within the stone. Few fossil skeletons communicate their purpose as clearly as those of the terror birds. Every major structure appears shaped around a single task, delivering force with extraordinary precision. The skull draws attention first. In the largest species, it was enormous, dominating the front of the body with a profile unlike that of any living land bird. Internal supports reinforced the structure through a network of thin bony struts, creating strength without excessive weight. The arrangement resembled engineering more than ornamentation, a framework designed to channel energy through specific directions. At the front sat a formidable beak. Its shape carried a familiar echo of modern birds of prey, though expanded to an entirely different scale. In some giant species, the beak alone reached 46 centimeters, which is about 18.1 miles. Curving downward near the tip, it formed a sharp hook suited for gripping flesh and directing impact toward a concentrated point. Closer examination reveals that the skull functioned differently from the heads of many modern predators. Mammalian hunters often rely on powerful jaws that clamp, wrestle, and maintain control during a struggle. Terror bird skulls show evidence of another strategy. Multiple joints were fused into rigid structures. Flexibility was reduced. Strength along a forward and downward axis became the priority. Supporting that skull was an equally specialized neck. The vertebrae changed shape along their length, with upper sections divided into paired projections and lower sections carrying tall attachment points for muscles. This arrangement produced a neck that could extend farther than its outward appearance suggested. Motion could be directed forward with speed, transferring momentum from body to beak in a concentrated strike. Biomechanical studies indicate that prey animals facing a terror bird may have encountered a reach greater than expected. A bird appearing to stand at one distance could suddenly project its head much farther forward. The movement combined extension, acceleration, and weight into a single action, increasing the effectiveness of each attack. Far below, the legs carried the rest of the design. Long bones and specialized joints indicate animals adapted for sustained movement across open terrain. Estimates suggest top speeds approaching 48 kilometers, which is about 29.8 miles, fast enough to close distance efficiently across grassland environments. Endurance and acceleration appear together in the skeleton, suggesting pursuit remained an important part of their hunting behavior. The feet added another layer of control. The second toe carried an enlarged curved claw that was often held clear of the ground while moving. Preserving its edge reduced wear. After an initial strike, the claw may have helped secure prey against the surface, while additional blows followed. Computer models and physical simulations have offered glimpses into the forces involved. Analyses conducted for documentary reconstructions demonstrated that the skull tolerated powerful vertical impacts while remaining less resistant to twisting stresses. One researcher compared the action of the beak to a hatchet. The comparison captures the mechanical principle well. Energy flowed downward through a rigid structure, focused into a narrow point, and delivered by the mass and momentum of the entire animal. Every feature worked toward that same purpose, creating one of the most distinctive predatory designs ever produced by evolution. A dynasty is usually measured in generations. The story of the terror birds is measured in geological ages, across changing climates, shifting landscapes, and the rise and fall of countless other animals. The family known as the Phorusrhacidae maintained its place among South America's dominant predators for roughly 60 million years. That achievement becomes even more impressive when viewed up close. The terror birds were never a single species marching unchanged through time. They were a diverse family containing at least 18 known genera spread across 5 major subfamilies. Some stood little taller than a person. Others reached heights approaching 3 meters, which is about 9.8 miles. Their differences allowed them to occupy a wide range of predatory roles while remaining part of the same evolutionary lineage. The smallest members belonged to a group called the Celopterinae. Standing around 1 meter tall, which is about 3.3 miles, they lacked the immense bulk of their larger relatives. Their bodies suggest agility, quick acceleration, and the ability to pursue smaller prey across open terrain. A landscape that might support one giant hunter could also support several smaller specialists moving through different ecological spaces. Higher up the size scale stood the Patagornithinae. These birds reached roughly 1.6 meters in height, which is about 5.2 miles. Paleontologists studying their proportions have noted how strongly adapted they appear for running. Their limbs were especially suited to sustained movement, giving them a level of cursorial specialization that exceeded many other members of the family. They likely covered large distances while searching for opportunities in grasslands and lightly wooded habitats. Beyond them rose the giants. The Phorusrhacidae and Physornithinae included the largest and heaviest forms known. These birds occupied the highest predatory positions available on the continent. Their size alone would have separated them from many competitors, allowing them access to prey resources unavailable to smaller hunters. An important feature of this long success was ecological partitioning. Species living in the same region often avoided direct competition by focusing on different prey sizes, hunting styles, or habitat preferences. One lineage might specialize in swift pursuit of small animals. Another could target larger prey. A third might operate in different terrain altogether. Through this division of labor, multiple terror bird species could exist side by side without destabilizing the broader system. The pattern appears repeatedly throughout their history. As one large species disappeared, another often emerged to occupy a similar role. Gigantism became a recurring characteristic of the family. Fossil evidence suggests that once very large body size evolved, it remained advantageous across vast stretches of time. Successive giant forms inherited the ecological position and maintained it through changing environmental conditions. Many famous predators seem permanent when viewed from a human perspective. Lions, wolves, and other modern hunters have become familiar symbols of dominance. Their histories, impressive as they are, occupy only a fraction of the time span covered by the Phorusrhacidae. For tens of millions of years, this family endured, diversified, adapted, and renewed itself. Individual species came and went, while the dynasty remained. Through that persistence, The terror birds became one of the longest lasting apex predator lineages ever known among vertebrate animals, a legacy written across much of the Cenozoic world of South America. Some discoveries arrive as scattered fragments, a tooth here, a bone there, each piece offering only a partial glimpse of a vanished animal. Then there are the rare finds that seem to step directly out of deep time, carrying enough detail to transform an entire field of study. Kelenken belongs to that second category. The story began in 2006 within the Colencura Formation of Patagonia, Argentina. A student named Guillermo Oscar Aguirre Zabala recovered a fossil that immediately stood apart from ordinary discoveries. Paleontologists soon recognized its significance. The specimen was formally described the following year, and the new species received a name honoring the young fossil hunter whose find brought it to light. What emerged from the surrounding rock was extraordinary. The skull measured 71 centimeters in length, which is about 28 inches. No larger bird skull has ever been discovered from any species known to science. Across all geological periods, among flying birds, flightless birds, hunters, scavengers, and giants of every kind, Kelenken remains the record holder. Its overall body matched the scale of its head. Estimates suggest a height of approximately 3 meters, which is about 9.8 feet. Weight calculations vary depending on the methods used, though most place the animal somewhere between 150 and 300 kilograms. Even the lower end of that range represents a predator of imposing proportions. Kelenken lived around 15 million years ago during the Middle Miocene, a time when open grasslands occupied increasing portions of South America. Those environments favored animals capable of covering large distances on foot. A hunter built for speed and powerful strikes would have found ample room to operate across such landscapes. The importance of Kelenken extends beyond its impressive size. Most terror bird fossils are frustratingly incomplete. Paleontologists often work from isolated bones, partial skulls, or scattered remains. Kelenken provided something far more valuable. Its skull survived in a nearly complete condition, preserving details that had previously been difficult to reconstruct with confidence. Researchers could finally examine the architecture of a giant terror bird in remarkable detail. The specimen revealed a massive beak measuring roughly 46 centimeters long, which is about 18 inches. More importantly, that beak was firmly integrated into a reinforced skull structure. The design supported growing evidence that these animals relied on concentrated impact forces rather than prolonged grappling struggles. Biomechanical analysis became possible in ways that earlier fossils had not allowed. Scientists tested how the skull handled stress, how force moved through the bones, and which movements the structure appeared best suited to perform. Each investigation strengthened the picture of a predator built around accuracy, momentum, and decisive strikes. Paleontologist Luis Chiap later reflected on the implications of such a skull. Speaking about Kelenken, he invited listeners to imagine the effect of an impact delivered by a head of that size. The comment captured the reaction shared by many researchers who encountered the fossil. Its name carries its own story. Kelenken was a powerful spirit from the traditions of the Tehuelche people of Patagonia. When paleontologists selected that name, they connected the bird to a figure already woven into the region's cultural memory. Looking at the immense skull recovered from Miocene rocks, the choice feels fitting. Few animals embody the image of a ruler more completely than Kelenken Guillermoy. A predator can often be understood by the marks it leaves behind in its own skeleton. Bones preserve habits long after flesh has vanished, and the skulls of terror birds tell a story very different from that of wolves, big cats or crocodilians. Their bodies point toward a hunting method that seems unusual even among the many predators Earth has produced. Most familiar hunters rely on gripping power. They seize prey, wrestle it to the ground, and maintain control through biting, suffocation, or coordinated attacks. Terror birds appear to have followed another path entirely. Their anatomy suggests speed, precision, and impact. The skull was not designed for prolonged struggle. It was designed to deliver force. Much of this understanding comes from studies of Andalgalornis stuleti, one of the best preserved members of the terror bird family. Researchers subjected digital reconstructions of its skull to biomechanical analysis, examining how the bones handled different stresses. The results revealed an unexpected limitation. The skull tolerated strong forces from above and below, yet performed poorly when stress came from the sides. That weakness carries important implications. A predator that routinely grappled with large, struggling animals would experience substantial twisting forces. Modern cats, for example, endure those stresses while holding prey. Crocodilians face similar demands when they clamp down and resist violent movement. Andalgalornis appears poorly suited for such encounters. Sideways loading created structural risks that would have made prolonged wrestling inefficient and potentially dangerous. The architecture of the skull excelled in another direction. Vertical force traveled through the reinforced bones with remarkable efficiency. When the head moved downward, stress dispersed through the structure in ways that minimized damage to the bird itself. This pattern supports a striking interpretation of how these animals hunted. Many researchers envision a predator that rushed forward across open ground, closed the final distance rapidly, and delivered powerful downward blows with its beak. The neck accelerated the skull like a living hammer. After impact, the head withdrew and struck again. Each motion concentrated force into a narrow point. Rather than maintaining contact with prey, the bird could create damage through repeated impacts delivered in quick succession. Some paleontologists compare the technique to a hatchet. The comparison does not imply a conscious tool, only a similar mechanical effect. Momentum, neck power, body mass, and a sharply hooked beak combined into a weapon capable of targeting vulnerable regions such as the skull, neck, or spine. Support for this idea comes from a living relative. The Seriema, a bird still found in South America today, captures prey and repeatedly slams it against hard surfaces. Lizards, snakes, and small animals are dispatched through impact rather than prolonged biting. The behavior offers a glimpse of what an enlarged descendant of the same lineage might accomplish when equipped with far greater size and strength. Speed completed the system. Estimates suggest some terror birds could reach approximately 48 kilometers per hour, which is about 30 miles per hour. In open grasslands, that pace allowed them to overtake many potential prey animals before evasive movements became effective. Debate continues regarding the largest prey they could kill. Some scientists argue that skull mechanics imposed limits. Others point toward the modified sickle claw, which may have helped restrain victims during an attack sequence. A damaged glyptodont skull, bearing injuries consistent with a terror bird strike, hints that at least some encounters involved animals of formidable size. The bones leave room for discussion, though they consistently portray a hunter unlike any dominant predator alive today. Among the many fossils uncovered from South America's Long Island chapter, few have caused more initial confusion than the remains of the Sebecidae. Their bones carried familiar features, yet the overall picture seemed wrong. Paleontologists recognized traces of crocodilian ancestry, but the animals standing before them in stone did not resemble the river hunters of today. They belonged to a lineage that had taken an entirely different road. Modern crocodilians are creatures of water's edge. Their bodies are low, their limbs spread outward, and much of their hunting depends on concealment within rivers, swamps, and lakes. Sebasids inherited the distant heritage of that group, though millions of years of independent evolution reshaped them into something suited for life on land. Their skeletons reveal animals that spent much of their existence moving across terrestrial landscapes rather than wading in waterways. The most striking difference appears in the limbs. Sebasids stood high above the ground on long legs, positioned more directly beneath the body. Researchers often compare their posture to that of mammals. This arrangement supported efficient movement across open terrain and allowed a style of locomotion that modern crocodilians cannot achieve. Instead of dragging themselves through short bursts before collapsing back into rest, these predators appear capable of sustained activity over considerable distances. Their skulls add another layer to the story. A modern crocodile possesses a broad snout filled with conical teeth designed to grip struggling prey. Sebasids carried narrower skulls and blade-like teeth compressed from side to side. Fine serrations lined the edges, creating cutting surfaces that paleontologists have compared to steak knives. Meat passed between those teeth very differently than it does inside the jaws of a living crocodilian. Viewed from certain angles, the head of a sebasid seems almost familiar for another reason. Its proportions evoke predatory dinosaurs more readily than modern reptiles. Deep jaws, narrow profiles, and slicing dentition created an appearance that repeatedly surprises researchers encountering reconstructions for the first time. Some specialists have even noted similarities between sebasid teeth and those of tyrannosaurs, despite the immense evolutionary distance separating the two groups. Among the largest members of the lineage was Baranasuchus arvaloi, a giant from the Miocene. Estimates suggest a body length of approximately 6 meters, which is about 19.7 miles. Correcting that comparison into a proper scale, 6 meters equals about 19.7 feet. At that size, Baranasuchus ranked among the most formidable predators the island ever produced. Its presence demonstrates that terror birds did not dominate alone. Multiple apex hunters shared the continent, each exploiting different opportunities within the broader ecosystem. The endurance of the Sebasidae is equally remarkable. Their history stretches from the aftermath of the Cretaceous-Paleogene extinction into the later Miocene, spanning tens of millions of years. Across changing climates and shifting landscapes, they remained an established component of South American predator communities without displacing the terror birds that evolved beside them. For a long period, scientists believed the story ended there. Then, in the year 2025, fossils from the Dominican Republic revealed something unexpected. Sebasids had survived on Caribbean islands roughly 6 million years beyond their supposed disappearance elsewhere. Small remnant populations lingered after mainland relatives had vanished, carrying the lineage through one final interval before the record closed. Their bones preserve the memory of a crocodilian experiment unlike any alive today. Predators often arrive carrying familiar shapes. A long-legged runner recalls a wolf. A heavy-jawed scavenger evokes a hyena. Saber-tooth bring to mind famous cats from the Ice Age. South America's island world produced animals that seemed to fit those patterns, yet their ancestry led somewhere entirely different. The group known as the Sparassodonta formed the third great predatory lineage of the continent. They were metatherians, close relatives of marsupials, though not true marsupials themselves. Across millions of years, they occupied ecological roles that elsewhere belonged to placental carnivores. Their existence stands as one of the clearest demonstrations of convergent evolution in the fossil record. Separated from North America, Eurasia, and Africa, South America never received the early ancestors of wolves, bears, cats, or hyenas. The ecological opportunities those animals filled elsewhere remained available. Evolution responded using the biological material already present on the island. From that foundation emerged Sparassodonts, predators whose appearance and behavior often echoed animals to which they were only distantly related. The earliest members appeared soon after the Cretaceous-Paleogene extinction. During the Paleocene and Eocene, they diversified rapidly. Some remained small hunters that likely pursued prey through forests and dense vegetation. Others expanded into larger body sizes, occupying niches between the giant birds and the terrestrial crocodilian relatives that shared the continent with them. Their range of forms was impressive. Certain species resembled elongated weasels in general build, suited for agility and quick movement. Other lineages developed powerful skulls, deep jaws, and muscular bodies capable of tackling much larger prey. This variety allowed Sparassodonts to occupy a broad spectrum of predatory roles across South America's changing environments. Among the most formidable was Probor hyena gigantea. Estimates place its body mass near 200 kilograms, which is about 441 pounds. That size made it the largest known predatory metatherian yet discovered. Its skull carried enormous crushing teeth capable of processing flesh and bone with substantial force. The family, known as the Probor hyenidae, illustrates the extent of this convergence. Their robust heads and heavy dentition resemble features seen in modern hyenas, though the two groups evolved independently on different continents. Similar ecological pressures shaped similar anatomical solutions. A predator benefiting from strong bite forces repeatedly arrives at comparable designs, even when the evolutionary pathways begin far apart. Other Sparassodonts followed different trajectories. Members of the Asymmetridae were more lightly built, with proportions that invite comparison to wolves. Their limbs suggest active pursuit and mobility. They occupied a different predatory niche, while remaining part of the same broader lineage. For tens of millions of years, this diversity persisted. Then a gradual decline began. By the Miocene, Sparassodont richness had reached its peak and was starting to contract. Fossil sites reveal fewer lineages, fewer species, and a shrinking presence across the landscape. What makes this decline particularly intriguing is its timing. The reduction occurred before northern placental predators arrived through the future Panama Connection. No invading wolves, bears, or cats can be blamed for the earliest stages of the collapse. Their disappearance remains one of South American paleontology's enduring puzzles. Ecological shifts, changing prey communities, climatic pressures, or competition within their own ecosystems have all been proposed. The evidence has yet to settle on a single explanation. The Sparassodonts ruled for millions of years, then faded from the record while the island still belonged to itself. Few fossils capture the imagination quite like a face armed with sabers. Across the history of life, elongated canine teeth evolved more than once, appearing in unrelated predators separated by geography and ancestry. On South America's long isolated continent, one of the most extraordinary examples emerged from a lineage that had no close connection to cats at all. Thylacosmolus atrox remains the most famous member of the Sparassodonta and one of the strongest demonstrations of convergent evolution ever discovered. At first glance, it appears strikingly similar to the saber-toothed cats that later roamed other parts of the world. The resemblance is so strong that early observers naturally compared it to Smilodon. Yet the similarity arose independently. The two predators inherited their traits from entirely different evolutionary histories, arriving at comparable solutions through parallel ecological pressures. Its name translates roughly as pouch knife, a reference to both its Metatherian heritage and the remarkable weapons extending from its upper jaw. Those canines rank among the most distinctive structures ever produced by a mammalian predator. They stretched downward in elegant curves, forming blades that dominated the animal's profile. Unlike the sabers of Smilodon, these teeth possessed open roots and continued growing throughout life, where at the tip could be compensated by ongoing growth from below. This arrangement meant the teeth functioned less like fixed structures and more like living tools that renewed themselves as years passed. Few predators in the fossil record evolved such an approach. Protection for those enormous canines came from another unusual adaptation. The lower jaw carried elongated bony flanges that extended downward like protective sheaths. When the mouth closed, the sabers rested alongside these structures. No other known saber-toothed animal developed this exact arrangement. The feature remains one of the clearest signs that Thylacosmolus followed its own evolutionary path rather than merely copying a familiar design. Body mass estimates vary considerably, ranging from roughly 41 kilograms, which is about 90 pounds, to 150 kilograms, which is about 331 pounds. Even the lower estimates place it among the more substantial predators of its ecosystem. The upper estimates elevate it into the ranks of the largest predatory metatherians ever documented. Its method of killing appears to have differed from that of many modern carnivores. Biomechanical studies indicate a comparatively modest bite force. Crushing bone or maintaining a powerful clamping grip was likely not its specialty. Researchers instead point toward the neck and head as the primary engines of attack. Strong neck muscles may have driven the sabers into prey through controlled downward motions, allowing the teeth themselves to perform much of the work. Recent research added another layer of intrigue. A study published in 2023 examined the arrangement of the eye sockets and found a configuration unlike that of any known predator. Their orientation suggests a visual system that remains difficult to interpret. Scientists continue to debate what this unusual anatomy meant for depth, perception, prey tracking, and daily behavior. The final chapter of Thylacosmolus carries its own correction to a popular story. It vanished approximately 3.3 million years ago. Smilodon did not arrive in South America until much later. More than 1 million years separated their histories. The marsupial saber-tooth disappeared before the famous cat ever set foot on the continent, leaving behind one of evolution's most distinctive experiments. Across much of Earth's history, dominant predators tend to push competitors aside. One lineage expands, another retreats, and ecological roles merge until only a few winners remain. South America followed a different path. For tens of millions of years, 3 major predator dynasties shared the continent, each thriving without erasing the others. The stability of that arrangement emerged from ecological partitioning. Every major predator group occupied a different place within the landscape, using different methods and pursuing different opportunities. Their coexistence was not a temporary accident. It persisted across spans of time, so immense that entire mountain ranges changed, while the basic structure of the ecosystem remained recognizable. On the open plains, terror birds held a position unlike any predator elsewhere on Earth. Their bodies favored movement across broad grasslands and savanna. Long legs carried them through country where visibility stretched toward distant horizons. Speed mattered here, precision mattered as well. Their anatomy points toward pursuit, followed by concentrated attacks delivered at close range. In those environments, few competitors possess the same combination of height, acceleration, and striking power. Elsewhere, the Sebasids occupied a different role. Their long limbs and elevated posture distinguish them from modern crocodilians, yet their bodies suggest hunters that benefited from cover, terrain features, and short bursts of movement. A predator waiting near vegetation, river margins, or broken ground faced different challenges from one crossing open grassland. The Sebasids appear to have met those challenges through a strategy shaped by ambush and rapid engagement. Between these extremes stood the Sparassodonts. Their diversity allowed them to spread across habitats that neither terror birds nor Sebasids fully occupied. Some remained relatively small, pursuing prey through forests and dense vegetation. Others grew into substantial predators, capable of challenging large herbivores. Their varied body forms created a bridge between ecological roles, filling spaces that might otherwise have remained vacant. Because each lineage specialized differently, direct competition was reduced. A pursuit hunter of open country, an ambush-oriented crocodilomorph, and a collection of Mediterranean carnivores could share the same continent while focusing on separate resources. The system developed layers, with each predator group interacting more strongly with particular prey and habitats than with one another. This arrangement extended through the herbivores as well. South America's prey animals followed evolutionary paths unlike those seen elsewhere. No tungulates browsed and grazed across many environments. Litopterns developed elegant body plans that later observers compared to horses or camels, despite lacking close relationships to either. Astropothers carried massive bodies and elongated snouts, resembling familiar animals from distant continents, while belonging to entirely separate branches of the mammalian tree. Each herbivore lineage had evolved within the same isolated world that produced the predators. Their defenses, behaviors, and ecological roles reflected local pressures accumulated over millions of years. Predator and prey shaped one another generation after generation, creating relationships found nowhere beyond the continent's shores. Viewed as a whole, the ecosystem possessed a remarkable efficiency. Predatory roles overlapped only where necessary. Herbivores occupied a wide range of feeding strategies. Resources moved through the food web with little redundancy. For geological ages, the arrangement endured, maintaining its structure through changing climates, shifting habitats, and the steady passage of deep time. A predator can reveal much about a landscape, yet the shape of an ecosystem is ultimately written by the animals it feeds upon. Across isolated South America, the herbivores were every bit as distinctive as the hunters that pursued them. They occupied familiar ecological roles, grazing, browsing, migrating, and shaping vegetation, but they arrived at those roles through evolutionary paths found nowhere else on Earth. Among the most successful were the toxodonts. Their best-known representative, Toxodon, carried a heavy body supported by sturdy limbs and a broad skull equipped with teeth adapted for processing abrasive plant material. Fossil evidence suggests an animal capable of thriving across a range of environments, from open country to wetter habitats. Its silhouette has often been compared to that of a rhinoceros, yet the resemblance reflects ecological convergence rather than close relationship. Toxodon belonged to a lineage entirely its own. Remarkably, it endured long enough to share the continent with the first human populations that entered South America. Another branch of this remarkable fauna produced Macrochania, a creature whose appearance puzzled naturalists from the moment its remains were discovered. During the voyage of the ship Beagle, Charles Darwin recovered fossils that resisted easy classification. The animal possessed a long neck, three-toed feet, and nasal openings positioned high on the skull. Those openings suggest the presence of a flexible proboscis, though its exact form remains uncertain. Reconstructions vary, yet all capture the same impression: a herbivore assembled from features that seem borrowed from several familiar animals while belonging to none of them. Far larger forms emerged as well. The astropothers reached impressive sizes and developed enlarged canine tusks projecting from the jaws. Evidence indicates that many species likely carried a muscular trunk. At a distance, they might have evoked comparisons to elephants, though their ancestry diverged from elephant lineages far deeper in time. Evolution repeatedly encountered similar ecological challenges and, working with different starting materials, produced comparable outcomes. These herbivores belonged largely to a broader collection known as the Meridiongullata, South America's native ungulates. For millions of years, they evolved without contact with horses, deer, cattle, antelope, or other hoofed mammals developing elsewhere. Isolation allowed experimentation on a continental scale. Body plans diversified, feeding strategies expanded, and ecological roles multiplied. The result was a community that mirrored many functions seen on other continents while remaining genetically distinct. Their existence illustrates one of evolution's recurring patterns. Similar environments often favor similar solutions. Grazers require efficient teeth for processing vegetation. Large browsing animals benefit from reaching food beyond the height available to smaller competitors. Herd-forming herbivores gain advantages through numbers and vigilance. Such pressures can guide unrelated organisms toward comparable forms, even when their histories share little in common. For immense stretches of time, these animals flourished alongside terror birds, Sparassodonts, and sebecids. Their bones fill fossil deposits across the continent, recording a world that operated according to its own ecological logic. Then the record changes. After the formation of the Panamanian land connection and the arrival of newcomers from the north, many native ungulate lineages declined and disappeared. Their fossils remain abundant in older layers, then fade with striking speed, leaving behind the final traces of one of Earth's most distinctive evolutionary experiments. Across millions of years, the island continent never stood still. Rivers altered their courses, rainfall patterns shifted, and plant communities expanded or retreated with changing conditions. The predators that ruled these lands were shaped by those transformations as surely as stone is shaped by water. Their history was written not only in bones and teeth, but also in the changing geography that surrounded them. Around 27 million years ago, Earth entered a cooler and drier climatic phase. Forests that had once occupied broad regions of South America began to contract across many areas. In their place came expanding grasslands and savannas. Open country spread across landscapes that had previously offered greater cover, creating habitats where speed and long-distance visibility became increasingly important. For herbivores, this shift altered feeding opportunities and movement patterns. For predators, it changed the very nature of the hunt. The terror birds proved exceptionally suited to this new world. Their bodies had already been shaped by life on land, yet the widening grasslands created conditions that favored even greater specialization. Long legs became increasingly valuable, where prey could be seen at a distance. Endurance and acceleration gained importance, where pursuit unfolded across open terrain. Through the Miocene, several terror bird lineages trended toward larger sizes, suggesting that these environments rewarded animals capable of covering ground efficiently while delivering overwhelming force once contact was made. Grassland expansion transformed the prey community as well. New grazing opportunities encouraged the success of herbivores adapted to feeding on tougher vegetation. Populations could spread across broader areas, and in some regions, larger herds likely became common features of the landscape. Every increase in prey abundance represented new opportunities for pursuit predators. Selection pressures moved in both directions, shaping hunters and hunted together through countless generations. Within this setting appeared Kelenken guillermoy, known from the largest bird skull ever discovered. Its fossils date to roughly 15 million years ago, near the height of grassland development across much of southern South America. The timing is difficult to ignore. A predator of such scale would have benefited from expansive terrain where vision extended far across the horizon and rapid movement could be maintained without dense vegetation obstructing pursuit. Evolutionary change often resembles a conversation conducted across immense spans of time. As grasslands expanded, predators capable of exploiting them gained advantages. Herbivores that escaped pursuit passed along traits favoring speed, awareness, endurance, or mobility. Predators then responded to those changes. Generation after generation, each side influenced the other. No conscious design guided the process. Natural selection adjusted the participants continuously, refining both pursuit and escape. What makes this chapter especially striking is its duration. South America remained isolated for such a long interval that these ecological interactions unfolded with relatively little interference from outside competitors. The open country predator role remained firmly occupied by terror birds, allowing the relationship between landscape, prey, and hunter to develop across millions of years. Climate altered the stage. Vegetation reshaped the scenery, and evolution answered each change with new forms, carrying the continent's remarkable experiment forward through deep time. Maps of the distant past often create the impression of complete separation, as though South America drifted through time behind an impenetrable wall. The reality was subtler. The surrounding ocean formed an extraordinary barrier, one that preserved the continent's distinct evolutionary path for tens of millions of years. Still, on rare occasions, chance found a narrow opening. A few travelers crossed waters that should have defeated them, arriving not as conquerors but as improbable survivors. The first of these visitors were the ancestors of the caviomorph rodents. Their descendants include familiar animals such as capybaras, chinchillas, and guinea pigs, yet their earliest arrival remains one of the most remarkable journeys in mammalian history. Fossils indicate they appeared in South America around 41 million years ago. Genetic evidence points toward Africa as their place of origin. At that time, the Atlantic Ocean was narrower than it is today, though it still stretched for immense distances. The leading explanation suggests that storms, floods, or river currents tore mats of vegetation from shorelines and carried small animals out to sea. Such voyages were acts of probability rather than intention. Most floating islands of vegetation would have vanished into the ocean with their passengers. A tiny fraction may have drifted far enough, long enough, to reach a new coastline. One successful crossing was all evolution required. From that single foothold emerged an enormous radiation of rodent species that would eventually occupy forests, wetlands, grasslands, and mountains across the continent. Many millions of years later, another unlikely arrival followed a similar path. The ancestors of the platyrrhine monkeys, known today as the New World monkeys, entered South America around 26 million years ago. Their closest relatives also lived in Africa, suggesting another transoceanic crossing. The journey likely covered several thousand kilometers, which is about 1,864 miles of open water. No bridge connected the continents. No chain of islands provided an easy route. Yet the fossil record indicates that the crossing happened, and the descendants of those pioneers eventually spread through tropical forests across much of the continent. These newcomers altered ecosystems, though they did so from lower levels of the food web. Rodents became important herbivores, seed dispersers, and prey animals. Monkeys occupied arboreal niches among branches and leaves. Their arrival added new threads to South America's ecological tapestry without unraveling the larger structure that had developed during isolation. Above them, the dominant predators retained their positions. Terror birds continued to patrol open landscapes. Sparassodont hunters maintained their varied roles. Land crocodiles persisted within their own ecological domains. None of these apex lineages faced meaningful competition from the ocean crossing arrivals because the newcomers entered entirely different niches. The significance of these events lies in their rarity. The barrier surrounding South America was permeable enough to admit a rodent clinging to drifting vegetation or a small primate carried by extraordinary circumstances. At the same time, it remained effective against large mammalian predators. Wolves never arrived, bears never arrived. Big cats remained absent for tens of millions of years. A narrow stretch of ocean, neither fully closed nor fully open, helped determine the character of an entire continent and the long persistence of its remarkable world. Far to the north of the great predator kingdoms, beyond the grasslands, forests, and river systems that had shaped South America for millions of years, the seafloor itself was beginning to change. No animal could have noticed it. No migration altered course because of it. Deep below the waves, geological forces were rearranging the future, one uplifted ridge at a time. For countless ages, a broad marine passage separated North America and South America. Ocean currents flowed freely through this gap, carrying water between the Atlantic and Pacific realms. Beneath that seaway, tectonic plates pressed against one another with immense persistence. The Pacific Plate and the Caribbean Plate met along a restless boundary where pressure accumulated over millions of years. Gradually, sections of sea floor rose upward. Volcanoes formed. Submerged ridges approached the surface. By roughly 15 million years ago, some of those volcanic peaks had emerged above the ocean. They appeared first as scattered islands, isolated fragments of land surrounded by water on every side. None formed a continuous bridge. A traveler moving between the continents still faced substantial stretches of open sea. Even so, the geography had changed. The once uninterrupted seaway now contained stepping stones extending across parts of the gap. Those islands created opportunities that had not previously existed. Storms, currents, floating vegetation, and chance could occasionally move animals from one landmass to another. The process remained rare, yet rarity means little when measured across millions of years. Given enough time, even unlikely crossings become possible. Among the earliest successful travelers were ground sloths from South America. Around 9 million years ago, some populations managed to move northward through the developing island chain. Their arrival in North America stands as one of the first clear biological exchanges between the continents. These pioneering migrants entered unfamiliar environments, while the larger geographical barrier still remained incomplete. Within South America itself, little seemed different. The dominant predator lineages continued to occupy their established roles. Open country hunters still ranged across grasslands. Other carnivores maintained their positions within forests, wetlands, and transitional habitats. The occasional movement of a species across scattered islands did not alter the structure of the ecosystem in any significant way. Ecological stability, refined across immense spans of time, remained largely intact. Yet geology possesses a patience unlike anything in biology. Each volcanic island represented more than a destination for wandering animals. It marked another stage in a transformation unfolding across millions of years. Every uplift narrowed portions of the marine barrier. Every change in topography altered currents, coastlines, and opportunities for dispersal. The process advanced so gradually that no generation could perceive its full direction. Throughout these developments, the great predators of South America continued their lives as they always had. Seasons passed, prey populations shifted with climate and vegetation. New generations inherited landscapes that appeared familiar. Above the surface, continuity prevailed. Beneath it, tectonic forces continued their work. The emerging archipelago did not yet connect the continents. Water still separated them. Even so, the first cracks in isolation had appeared. What began as scattered volcanic islands introduced a new possibility into a world that had long remained apart, and the geography of the Americas moved one step closer to a different arrangement of land and life. A line that had existed for tens of millions of years disappeared without ceremony. No mountain collapsed, no single eruption announced the moment. Grain by grain, layer by layer, the final openings between North America and South America filled with sediment and volcanic rock until the connection was complete. Around 2.8 million years ago, the continents touched. For roughly 60 million years, South America had existed as a biological island, separated from the larger continental networks beyond its shores. Now, a continuous pathway stretched across the newly formed Isthmus of Panama. Animals that had evolved in isolation could move between worlds for the first time since the aftermath of the Cretaceous-Paleogene extinction. The consequences reached far beyond the movement of wildlife. Ocean circulation changed as the Central American Seaway closed. Waters that had once flowed freely between the Atlantic and Pacific Oceans found their routes blocked. Atlantic currents were redirected northward, strengthening circulation patterns that would eventually contribute to the development of the Gulf Stream. Across the northern hemisphere, climatic systems shifted, ice sheets expanded. The planet entered a new chapter marked by recurring glacial cycles. While those global transformations unfolded across immense regions, another process began almost immediately along the land bridge itself. Species started crossing in both directions. Paleontologists call this event the Great American Biotic Interchange, one of the most significant migrations in the history of mammal evolution. The travelers arriving from the north carried the legacy of a very different evolutionary world. For millions of years, North America had remained connected to Eurasia through intermittent land routes, allowing repeated exchanges of animals. Predators there evolved amid continual competition. Foxes, bears, ancestral wolves, and ancestral members of the cat lineage emerged from ecosystems crowded with competitors. Generation after generation, natural selection, refined hunting strategies, sensory abilities, and ecological flexibility. South America offered opportunities that these newcomers had never encountered. The continent possessed abundant prey and predator communities shaped under conditions of prolonged separation. Many ecological roles resembled those elsewhere on Earth, yet the species occupying them came from entirely different evolutionary histories. Movement also flowed northward. Xenarthrans crossed the bridge in the opposite direction. Ground sloths lumbered into unfamiliar territories. Armadillos expanded beyond their ancestral homeland. Glyptodonts, protected by domed armor, followed pathways that had never previously existed. For a brief geological interval, animals from two long divided worlds mingled across a shared landscape. At first, the established order within South America still appeared durable. Terror birds continued to patrol open habitats. Land crocodiles persisted in their remaining strongholds. The last Sparassodont lineages survived as they had for ages. Daily life continued beneath familiar skies, even as new footprints appeared along migration corridors. Yet the character of the continent had changed in a way that could not be reversed. Isolation, the condition that had shaped every predator, herbivore, and scavenger discussed throughout this journey, no longer defined the land. A gate that had remained closed since the age of dinosaurs now stood open. Species crossed in growing numbers, carrying with them evolutionary histories forged elsewhere, and the balance that had endured across millions of years entered a different state from which it would never return. Nothing about the interchange resembled a single invasion. No moment exists in the fossil record where the old world ended and the new one began. Layer after layer of sediment preserves a more gradual story, one measured in migrations, breeding populations, and expanding ranges. Across millions of years, animals from North America appeared in South American deposits with increasing frequency, each arrival adding another thread to a changing ecological tapestry. The earliest newcomers to establish lasting footholds were herbivores. Horses spread into open landscapes that had long supported South America's native grazing animals. Tapirs entered forests already occupied by distinctive local browsers. Deer followed pathways through woodlands and grasslands, feeding on resources that had previously sustained lineages found nowhere else on Earth. These arrivals did not immediately erase the older fauna, yet they introduced competitors shaped by different evolutionary histories and different selective pressures. Predators followed in stages. Members of the carnivore lineage crossed the land bridge and gradually expanded southward. Bears appeared. Cat ancestors entered new territories. Later came pumas, adaptable hunters capable of thriving across varied habitats. Among the most famous arrivals was Smilodon populator, the saber-toothed cat that eventually became one of the largest feline predators known from the fossil record. Its broad chest, powerful forelimbs, and elongated upper canines made it a formidable presence within the transformed ecosystems of the continent. Popular retellings often describe Smilodon as the conqueror that replaced Thylacosmolus. The chronology tells a different story. Thylacosmolus disappeared more than 1 million years before Smilodon reached South America. The decline of that unusual predator had already unfolded within the continent itself. When the saber-toothed cat arrived, the ecological stage it entered was already changing. What the northern carnivores carried southward extended beyond claws and teeth. They emerged from ecosystems where predators had spent immense spans of time competing against one another. Competition among bears, canids, felines, and other hunters produced a diversity of feeding strategies and behavioral adaptations. Their prey had evolved alongside those pressures, creating long evolutionary contests that shaped both sides of the relationship. Many native South American herbivores had never encountered predators built according to those particular rules. Their ancestors had coexisted with terror birds, Sparassodonts, and other hunters whose methods differed substantially. Escape responses, vigilance behaviors, and habitat use had been molded by those older threats. As new predators spread across the continent, familiar strategies may not always have provided the same degree of protection. The fossil record reflects this imbalance. Research published in the Proceedings of the National Academy of Sciences during 2020 suggested that the interchange was driven less by explosive diversification among northern arrivals and more by elevated extinction rates among native South American mammals. The newcomers expanded, yet the more striking pattern was the disappearance of long established lineages. Across plains, forests, and river valleys, the composition of life shifted generation by generation. Species that had evolved during tens of millions of years of isolation now shared landscapes with arrivals from a connected continental world. The exchange remained gradual in pace, though its cumulative effect reached every corner of the continent, altering ecological relationships that had endured since the distant aftermath of the dinosaurs. Across the newly connected continents, most stories flowed in a single direction. Northern animals expanded southward, spreading through habitats that had remained isolated for tens of millions of years. Amid that broad movement, one predator chose a different path. While many native South American lineages were entering periods of decline, a member of the terror bird family stepped onto the land bridge and headed north. Its name was Titanis walleri. The journey itself was extraordinary. Terror birds had evolved on a continent separated from the rest of the world since the aftermath of the Cretaceous Paleogene extinction. Their rise, diversification, and dominance belonged to ecosystems unlike any found elsewhere. Yet, when the barrier vanished, Titanis became the only large South American predator lineage known to establish itself successfully in North America. Fossils discovered in Texas and Florida reveal a bird that remained unmistakably part of the Forest-racid tradition. Titanis stood roughly 2.5 meters tall, which is about 8.2 feet. Powerful legs supported a body built for movement across open ground. Its beak retained the deep, hooked shape characteristic of its relatives, a structure suited for delivering forceful strikes. Although smaller than the giant Kelenken, Titanis still ranked among the largest avian predators ever to walk the earth. North America offered a very different ecological stage. Cats, bears, canids, and numerous other carnivorous mammals already occupied the landscape. Titanis entered a continent crowded with predators whose ancestors had spent millions of years competing against one another. Even so, the bird endured. Its fossil record spans more than 3 million years, indicating a stable and successful presence rather than a brief excursion beyond its homeland. That persistence complicates the common image of terror birds as helpless victims of the interchange. The family was under pressure in South America, yet Titanis demonstrated that at least one branch remained adaptable enough to colonize entirely new environments. It crossed unfamiliar terrain, established breeding populations, and survived through many generations far from the continent where its lineage originated. The timing is especially revealing. During the same broad interval in which northern mammals expanded southward, Titanis was proving that ecological exchange moved in both directions. The story was never one of a single victorious fauna replacing another overnight. Nature rarely follows such simple scripts. Different lineages responded in different ways, some retreating, some persisting, and some expanding into opportunities created by the newly connected world. Eventually, Titanis disappeared. Current evidence places its extinction around 1.8 million years ago. That date arrives long before the first humans entered North America, eliminating an idea that once gained popularity, the suggestion that early people hunted the bird into extinction. Titanis vanished without any human witness. Even then, the broader terror bird story had not fully ended. Fossils from Uruguay, possibly belonging to a small species of Celopterus, suggest that members of the family survived until roughly 96,000 years ago. By that time, the giants had already passed into history. What remained were scattered holdouts, lingering in isolated corners of the continent where the echoes of an older South America endured a little longer before fading from the record. A continent can spend millions of years writing a story, then erase its leading characters one chapter at a time. South America's great predators did not vanish in a single catastrophe. Their departures were staggered across immense spans of time, separated by climates, landscapes, and ecological changes that unfolded far too gradually for any living creature to perceive. The first lineage to disappear was the Sebecidae. These terrestrial crocodile relatives had once occupied predatory roles unlike those of modern crocodilians. Their bodies were built for movement on land. Their legs carried them high above the ground, and their teeth were suited for slicing flesh. Fossils indicate that they vanished from mainland South America roughly 11 to 12 million years ago. This extinction occurred long before the Isthmus of Panama closed, and long before northern predators entered the continent in substantial numbers. Whatever ended the Sebecids appears to have come from within South America itself. Shifting habitats, changing prey communities, or ecological pressures, still imperfectly understood, likely played their part. The fossil record preserves their disappearance, yet leaves the final details unwritten. The Sparassodonta followed a different path. For millions of years, these marsupial relatives occupied predatory niches, ranging from small hunters to formidable apex carnivores. Their diversity gradually narrowed through the Miocene. Species disappeared, ranges contracted, and the lineage entered a prolonged decline. By approximately 3.3 million years ago, the last known thylacosmelids had vanished. Their extinction arrived before Smilodon and other large northern carnivores established themselves in South America. Popular images of invading saber-toothed cats, directly replacing Thylacosmilus, do not match the chronology preserved in stone. The marsupial predators were already fading before those newcomers arrived. One lineage remained. Across grasslands and open country, the terror birds continued their long reign. Their family history stretched back through much of the Cenozoic era, surviving climatic shifts, environmental transformations, and repeated ecological reorganizations. Even after continental connection altered the balance of South American life, terror birds persisted. Titanis carried the lineage into North America, while relatives still occupied portions of their ancestral homeland. Gradually, however, the record thins. Fossil deposits from Argentina, Uruguay, and Brazil preserve fewer appearances. The largest forms disappear first. Medium-sized species linger longer. Smaller members of the family continue for additional stretches of time, surviving in habitats that may have offered temporary refuge as ecosystems changed around them. No sharp boundary marks their end. The pattern resembles a constellation losing stars one by one across a darkening sky. The last known large terror bird fossils date to roughly 1.8 million years ago. By then, the grassland world that had sustained forest-racid dominance for tens of millions of years had been transformed. New herbivores moved across the landscape. New predators occupied hunting grounds. Ecological relationships that once endured across geological ages no longer held the same stability. Taken together, these three predator lineages ruled South America for a span far exceeding the entirety of recorded human history. Across most of the Cenozoic era, crocodile relatives, marsupial hunters, and giant predatory birds shaped the continent's food webs. Their reign ended gradually, species by species, leaving only fossils to trace the long fading of a world that had once stood apart from every other on Earth. Few chapters in this story end with a clear final sentence. The disappearance of the terror birds remains one of the enduring debates of South American paleontology, a puzzle assembled from scattered fossils, shifting climates, changing ecosystems, and timelines that refuse to fit neatly into a single explanation. Their extinction was real enough. The cause remains elusive. One proposal centers on competition. After the formation of the land connection between the continents, members of the order Carnivora entered South America in growing numbers. Cats, dogs, bears, and related predators arrived from ecosystems where countless lineages had spent millions of years competing against one another. Their hunting strategies, sensory abilities, and ecological flexibility were products of a long evolutionary contest. At first glance, this seems like a convincing explanation. New predators appeared, old predators disappeared, yet the fossil record complicates the picture. Terror birds survived for millions of years after the interchange began. They did not vanish immediately upon encountering northern competitors, suggesting that competition alone cannot fully account for their decline. Another possibility focuses on prey. For tens of millions of years, terror birds hunted animals that had evolved alongside them. Native ungulates such as toxodons, macrauchenias, and several other South American herbivores formed part of a familiar ecological network. During the interchange, many of these long-established prey species entered decline. Their populations shrank, their distributions changed, and some eventually vanished altogether. A predator shaped by deep time to pursue particular kinds of prey may have faced increasing difficulty when those prey disappeared. Newly arriving herbivores brought different behaviors, different movement patterns, and different ecological relationships. Adaptation may not have kept pace with the transformation unfolding across the continent. Climate offers another piece of the puzzle. The beginning of the Pleistocene ice ages altered weather systems around the world. South America experienced shifts in rainfall, temperature, and vegetation. Grasslands expanded in some regions and contracted in others. Ecological boundaries moved across the landscape. Large pursuit predators depend on habitats that support both visibility and suitable prey densities. Even gradual environmental changes can reshape those conditions over long stretches of time. No fossil layer points to a single climatic catastrophe, yet cumulative changes may have steadily reduced the advantages that once favored giant predatory birds. Some researchers have also explored habitat fragmentation. As northern herbivores spread through South America, grazing patterns changed. Plant communities responded. Open spaces could become patchier, interrupted by vegetation structures different from those that existed during earlier phases of terror bird evolution. A hunter adapted to covering ground rapidly across broad terrain may have encountered a landscape that no longer rewarded the same strategy. What emerges from these competing ideas is a picture of complexity. None of the major hypotheses fully explains every detail. Each contributes part of the story. Paleontologists generally agree on one broader pattern. Native South American species suffered disproportionately during the interchange, while many northern arrivals expanded successfully into new territory. The mystery becomes even more intriguing when viewed alongside Titanis. At roughly the same time that terror birds were declining in their homeland, one branch of the family maintained established populations in North America. That contrast suggests the birds themselves were not inherently destined for extinction. Something within the changing ecological fabric of South America altered the conditions that had sustained their dominance for so long, leaving behind a question that remains open today. The ending did not belong only to predators. Across South America, entire communities of herbivores that had evolved in isolation for tens of millions of years were also entering their final chapters. Their decline unfolded across plains, forests, wetlands, and river valleys, touching nearly every branch of the continent's unique mammalian heritage. The hunters were disappearing, but so too were the animals that had shaped the landscape through their feeding, migration, and sheer presence. Among the last survivors stood Toxodon. Heavy-bodied and broad-headed, it occupied a role loosely reminiscent of a rhinoceros, though its ancestry followed a completely different path. Fossils collected during the voyage of Charles Darwin first brought this remarkable animal to scientific attention. Toxodon endured through the climatic fluctuations of the Pleistocene and remained part of South American ecosystems until roughly 12,000 years ago. For millions of years, it had weathered environmental change, continental connection, and ecological upheaval. Then its record ended near the boundary separating the Ice Age world from the modern one. Macrauchenia followed a similarly long journey. Its appearance combined features that seemed borrowed from unrelated creatures. A long neck rose above a sturdy body, while its probable trunk gave it a profile unlike anything living today. Darwin found its remains puzzling, and later generations of scientists continued debating aspects of its biology. Like Toxodon, it survived far beyond the initial stages of the Great American Interchange. Fossils place it within landscapes already occupied by early human populations, making it one of the final representatives of a lineage whose roots stretched deep into South America's isolated past. Other survivors endured for impressive spans of time as well. Giant ground sloths continued roaming portions of the continent long after northern arrivals became established. Glyptodonts, protected by immense armored shells, persisted through changing climates and shifting ecological balances. These animals were not swept away immediately by contact with newcomers. Many coexisted with immigrant species for millions of years. Their eventual disappearance emerged through a drawn-out process rather than a sudden collapse. Research examining extinction patterns across the interchange has revealed an important detail. Direct predation appears insufficient to explain the scale of loss. Competition often provides a stronger explanation. North American ungulates entered habitats already occupied by native herbivores. They consumed similar resources, browsed similar vegetation, and occupied comparable ecological positions. Across countless generations, even modest advantages in reproduction, feeding efficiency, or adaptability could reshape entire communities. The struggle unfolded gradually, measured in population trends rather than dramatic encounters. As these pressures accumulated, the distinctive character of South American ecosystems began to fade. Species that had no counterparts elsewhere disappeared one after another. Entire evolutionary experiments, refined over immense spans of time, approached their conclusions. The losses extended far beyond individual animals. Unique relationships between plants, herbivores, predators, and landscapes unraveled as familiar participants vanished from the system. From a geological perspective, the transformation happened with startling speed. A continent that once hosted one of Earth's most unusual collections of mammals became increasingly populated by forms whose relatives already existed across much of the wider world. The fossil record preserves this transition layer by layer. Within those layers rests the story of a fauna that flourished in isolation, endured remarkable change, and ultimately yielded much of its uniqueness within a comparatively brief moment of deep time. Footprints crossed the new continent in both directions. While many of South America's oldest lineages were entering periods of decline, others were beginning journeys that would carry them far beyond the landscapes in which they had evolved. The newly formed land connection did not serve only northern migrants. It also opened a route for creatures shaped by 60 million years of isolation to enter ecosystems unlike any they had previously known. Among the most striking travelers were the giant ground sloths. Their lineage had originated on the southern continent long before the land bridge existed, and when the passage finally opened, several species expanded northward with surprising success. Fossils of these animals have been discovered across an immense geographic range, stretching from Patagonia to Alaska. Their spread reveals a capacity for adaptation that is easy to overlook when viewing them through the lens of their eventual disappearance. Megatherium stood among the largest of all, reaching roughly 6 meters in length, which is about 3.7 miles, and weighing between 4 and 6 metric tons. It occupied a scale few land mammals have ever matched. Supported by massive limbs and equipped with formidable claws, it moved through environments that varied from open country to wooded regions. In North America, relatives of these giant sloths became established members of ecological communities already inhabited by horses, camels, mammoths, and numerous predators. Their presence demonstrated that animals forged within South America's long isolation could flourish beyond their homeland. Another successful emigrant wore armor instead of towering height. Glyptodonts, relatives of modern armadillos, carried enormous bony shells that enclosed much of their bodies. Some possessed tails reinforced by dense bone, forming structures capable of delivering powerful blows. Their appearance recalled a living fortress moving across the landscape. After crossing northward, they spread through portions of what is now the American Southwest and remained there through much of the Pleistocene. For millions of years, they occupied habitats far removed from the continent where their lineage first emerged. Smaller armored descendants also joined the migration. Giant armadillos expanded into North America and established populations across broad regions. Their legacy survives today through the nine-banded armadillo, a species that continues extending its range northward. Each new population carries with it a fragment of an evolutionary story that began on an isolated southern landmass many millions of years earlier. One traveler proved especially enduring. Opossums, members of a Metatherian lineage with roots deep in South American history, crossed the land bridge and succeeded where many others eventually vanished. Today, they remain the only marsupials living naturally in North America. Their continued existence provides a living connection to ecosystems that disappeared long ago, a reminder that some threads of the old island world still persist. Ground sloths became particularly important components of northern ecosystems. They shared the continent with woolly mammoths, native horses, camels, and eventually the first human populations to arrive. Their success carried an important lesson. Many South American animals were fully capable of surviving and prospering in new environments. The contrast between thriving emigrants in the north and declining relatives farther south suggests that the decisive forces were rooted less in the animals themselves than in the changing ecological conditions that followed the Great Interchange. By the time human footsteps appeared on the American continents, the long drama of isolation and exchange was already deep into its final act. The land bridge had existed for millions of years. Northern and southern animals had mingled, competed, spread, and vanished. Entire lineages that once dominated South America had already disappeared from the stage. Yet the continent still held living remnants of the old island world, survivors whose ancestry stretched back through a history far older than humanity itself. Somewhere between 15,000 and 20,000 years ago, people moved into this transformed landscape. They entered a continent where creatures from two evolutionary realms shared the same horizons. Herds still crossed the plains. Giant mammals still shaped vegetation with their feeding. The ecological experiment that had begun after the extinction of the dinosaurs had not completely ended. Among the animals these early people may have encountered was Toxodon, its lineage traced back through tens of millions of years of South American history. With its heavy body, broad head, and durable grinding teeth, it remained a familiar grazer of open habitats. Fossils collected centuries later by Charles Darwin would help reveal its existence, though even Darwin struggled to understand where such an animal belonged on the tree of life. By the arrival of humans, Toxodon represented one of the last living echoes of a world that had once evolved in remarkable isolation. Macrauchenia also endured into this period. Its appearance still seems unusual today, with a long neck, sturdy limbs, and nasal openings positioned high on the skull. Whether it possessed a short trunk or another soft tissue structure remains uncertain, but its form reflected evolutionary pathways found nowhere else. For countless generations, it had survived climatic shifts, biological invasions, and ecological restructuring. Human beings arrived while these distinctive herbivores were still moving across South American landscapes. Elsewhere, giant ground sloths continued their long story. Some species weighed several tons and stood among the largest land mammals of their age. Archaeological evidence indicates that humans and ground sloths overlapped in South America, creating encounters between a newly arrived primate and animals whose ancestry reached into a distant chapter of mammalian evolution. Such meetings joined two histories that had previously unfolded on entirely separate paths. Around 12,000 years ago, a broad extinction wave swept across many regions of the world. In South America, numerous surviving members of the old island fauna disappeared during this interval. Researchers continue to debate the balance between human hunting and environmental change associated with the end of the Ice Age. Shifting climates, altered habitats, and resources, expanding human populations introduced new pressures. The exact contribution of each factor remains an active area of study. The outcome itself is far less uncertain. By roughly 10,000 years ago, most of the great survivors of South America's isolated past had vanished. Toxodon was gone. Macrauchenia was gone. Many giant ground sloths disappeared as well. The process initiated when the land bridge connected two continents finally reached its conclusion. What remained was a new ecological world, one shaped by interchange, extinction, adaptation, and arrival. The landscapes endured, but the community that had supported the reign of the terror birds belonged entirely to history. A pattern emerged only after countless fossils had been collected, cataloged, and compared across two continents. At first glance, the Great American Interchange seemed straightforward, a mutual exchange made possible by a newly formed land bridge. Species moved north, species moved south. Pathways opened, migrations followed, and ecosystems changed. Yet when paleontologists began measuring the long-term outcome, the balance proved unexpectedly uneven. Modern South America contains many mammals descended from northern arrivals. Deer, canids, felids, and numerous other groups trace their presence to ancestors that crossed the Isthmus of Panama after the continents connected. Looking north reveals a different picture. Some South American lineages certainly established themselves there, but their representation is far smaller. The interchange flowed in both directions, though its legacy remained weighted heavily toward one side. For much of the 20th century, a common explanation appeared persuasive. Northern species had evolved within a larger, connected world, where competition involved a greater number of predators, herbivores, and ecological pressures. Many researchers proposed that these animals were therefore better equipped for expansion. According to this interpretation, North American migrants entered South America and succeeded because they were inherently more competitive than the native fauna they encountered. As fossil databases expanded and statistical methods improved, that conclusion began to face closer scrutiny. A study published in the Proceedings of the National Academy of Sciences in 2020 by Juan David Carrillo and colleagues examined diversification and extinction patterns across the interchange in far greater detail. Their results suggested a different story. The imbalance was driven less by exceptional northern success and more by unusually severe losses among South America's native animals. This distinction matters because it changes the underlying narrative. The fossil record indicates that northern migrants did not undergo an extraordinary evolutionary explosion after arriving in South America. Instead, many native groups disappeared at elevated rates, leaving ecological vacancies behind. As those vacancies accumulated, incoming species expanded into opportunities that had previously been occupied. The final outcome appeared similar on the surface, yet the mechanism beneath it was fundamentally different. Why extinction struck the southern fauna so intensely remains a subject of continuing investigation. Climatic instability likely contributed. Changing vegetation patterns may have altered food resources and habitat structure. Competition among herbivores appears to have played a role as well. Predators from the north also entered the equation. Members of the order Carnivora, including ancestors of foxes, bears, cats, and dogs, show statistical associations with increased extinction among native South American mammals. Their arrival introduced hunting strategies shaped through long histories of interaction with diverse prey and competing predators. No single factor fully explains the pattern. The evidence instead points toward multiple pressures acting together across long stretches of time. Species that had evolved under the conditions of isolation encountered a biological landscape transformed by newcomers, shifting climates, and changing ecosystems. The asymmetry remains visible today. Across South America, many familiar mammals descend from lineages that once arrived from the north. Their presence forms a living record of the moment when the continent's long separation ended. The seal that had protected an evolutionary world for 60 million years finally opened, and the consequences remained etched into the fauna that followed. The story lingers in forms that still breathe. Long after the great predator dynasties vanished and the island world dissolved into a connected continent, traces of that lost age remained woven into living creatures, landscapes, and ecological relationships. South America carries these remnants openly, though they are easy to overlook without the perspective of deep time. A traveler moving through the continent today may encounter animals whose ancestry reaches back to the long period of isolation. The giant anteater, with its elongated skull and deliberate search for insects, belongs to Xenarthra, one of the distinctive mammal groups that evolved while South America stood apart from the rest of the world. Nearby, giant armadillos and three-banded armadillos continue their lives across forests, savannas, and grasslands. Their bodies represent lineages that endured tectonic upheaval, climatic shifts, biological invasions, and mass ecological restructuring. They remain among the last living heirs of an evolutionary experiment that lasted roughly 60 million years. The capybara offers another glimpse into that inheritance. Resting along riverbanks or moving through wetlands in social groups, it descends from rodents whose ancestors arrived from Africa around 41 million years ago. Those distant voyagers crossed an ocean on natural rafts of vegetation and debris, eventually giving rise to a remarkable radiation of South American forms. The capybara survived every transformation that followed. Continents connected, predator guilds changed, climates oscillated, and entire faunas disappeared, yet this lineage persisted. Other survivors tell a different story. Tapirs are descendants of immigrants from the north. Their ancestors crossed the land bridge during the interchange and found opportunities within South America that proved enduring. While tapirs declined across much of North America, they remained successful farther south. Their continued presence reflects how the interchange reshaped both continents in unequal ways, creating losses in some regions and refuges in others. High above mountain slopes and open country, the Andean condor circles on rising air currents. It belongs to a lineage distinct from the terror birds, yet its silhouette recalls a continent where giant birds once occupied prominent ecological roles. The condor feeds as a scavenger, not an active pursuit hunter, but its immense wingspan preserves the image of avian dominance upon the landscape. In that sense, it serves as a distant echo carried forward into the present. The land itself also preserves memory. Across Argentina and Uruguay, grasslands extend toward horizons, shaped through long interactions between grazing animals and the predators that pursued them. Ecologists studying these environments recognize patterns created over immense spans of time. Vegetation, movement corridors, feeding pressures, and habitat structure all emerged through countless generations of adaptation. The original participants have largely vanished, yet portions of the stage remain. Seen through this lens, modern South America becomes more than a collection of surviving species. It is a living archive. Every armadillo crossing a path, every capybara beside a river, every condor tracing circles above the Andes carries fragments of a world that once stood apart. The island is gone, though its biological memory continues to move across the continent in enduring forms. A voice carries across the grass before the bird itself comes into view. It rises in a sequence of sharp notes, travels over open country, and lingers in the air long after the caller has fallen still. The sound belongs to the Seriema, a bird of the South American plains whose presence offers one of the closest living connections to a vanished age. Standing around 80 centimeters tall, which is about 31 inches, the Seriema appears modest beside the giants that once dominated the continent. Long legs lifted above the grasses. A narrow body moves with confidence across the ground. Its beak ends in a small hook, hinting at habits shaped by predation. Across parts of Brazil, Bolivia, and Argentina, it spends much of its life walking and running through landscapes that still preserve echoes of older ecological patterns. To paleontologists, The Seriema is more than a modern bird. It belongs to the order Cariamiformes, the same broader lineage that produced the terror birds. Every observation of its behavior becomes a valuable clue. Fossils preserve bones, proportions, and anatomy, yet behavior rarely fossilizes. Living relatives provide a rare opportunity to glimpse actions that may have deep evolutionary roots. One hunting behavior has attracted particular attention. When a Seriema captures prey, it often grips the animal in its beak and strikes it repeatedly against the ground. The motion is forceful, precise, and efficient. Small reptiles, rodents, and other prey can be subdued through these repeated impacts. Researchers studying the skull mechanics of terror birds have noted intriguing parallels. The reinforced skulls and powerful necks of the giant forms appear well suited for delivering strong downward blows. Although no living observer ever witnessed a terror bird hunt, the Seriema offers a possible behavioral reference point, scaled down to a much smaller body. Movement provides another connection. Seriemas are capable flyers, yet they frequently rely on running. They pursue prey across open terrain and often escape danger on foot before taking to the air. Watching one move across grassland gives a sense of how a ground-focused, predatory bird can operate with speed, balance, and endurance. In the distant past, those same qualities reached their fullest expression in relatives that abandoned flight entirely. Evidence from fossils adds another layer. Studies of the inner ear of the terror bird Lalawavis scagliae suggest sensitivity to low-frequency sounds. Such hearing may have helped detect large animals moving across open habitats. Vibrations, distant calls, and the rumble of herds could have carried information across considerable distances. The Seriema inhabits comparable environments, where sound travels freely through broad expanses of grass and scrub. Its own call feels larger than the bird producing it. Ornithologists have long remarked upon the strength and carrying power of the Seriema's voice. The notes can travel for kilometers, which is about 0.62 miles across favorable conditions. Listening to that cry drifting over the plains, one can imagine a lineage whose body diminished through time while traces of its older presence endured. The Seriema remains, a living fragment of a world otherwise known through stone, carrying forward the final spark of a story that lasted 60 million years. Some stories seem destined from the moment they begin. Others depend on a chain of circumstances so delicate that changing a single link would transform everything that followed. The history of South America's island world belongs to the second kind. Its rise, endurance, and eventual collapse emerged from geological events that unfolded over immense spans of time, yet the precise path was never guaranteed. The land bridge that ultimately connected the continents grew from tectonic movements operating for millions of years. Plates shifted, ocean floors rose, volcanic arcs emerged, and channels narrowed. Those broad processes followed the laws of geology. Yet the details mattered. The timing of uplift, the accumulation of sediment, and the persistence of remaining waterways influenced exactly when the final connection formed. A difference measured in millions of years may sound insignificant beside the age of continents, but for evolving ecosystems, it can alter entire destinies. Imagine the connection forming 10 million years earlier. At that point, the ecological landscape of South America would have been different from the one that eventually confronted northern arrivals. Predator lineages occupied other stages of their history. Herbivore communities contained different balances of abundance and diversity. Evolutionary experiments, still unfolding, might have encountered foreign competitors before reaching maturity. The interchange would have occurred on a different biological stage, producing outcomes impossible to reconstruct with certainty. The reverse possibility is equally striking. If closure had been delayed by 10 million years, countless generations would have continued within isolation. Selection pressures would have remained internal. Predator and prey would have continued shaping one another without interference from northern immigrants. Entire branches of evolution might have taken directions that never came to pass in the world we inherited. An even more intriguing possibility emerges from the simple notion that the final gap never closed at all. In that alternate history, South America remains a continental island. The great ecological drama continues under its own rules. Terror birds still patrol open country. Native predator lineages continue adapting to familiar competitors. Distinct herbivores maintain evolutionary relationships that began tens of millions of years earlier. The continent becomes a living counterpart to another surviving experiment in isolation. Australia provides a useful comparison. Its long separation preserved marsupial lineages that diversified into ecological roles filled elsewhere by placental mammals. Kangaroos, quolls, and wombats reflect pathways shaped by isolation. Their existence demonstrates that continental scale experiments can persist when barriers remain intact. Comparing Australia with South America reveals how profoundly biological history can change when those barriers disappear. From this perspective, the collapse of South America's island world was not written into the fabric of the universe. It emerged from a particular sequence of geological developments that happened to occur. Change one element of that sequence, and the outcome shifts. Evolution would still proceed, continents would still transform, and ecosystems would still adapt, yet the cast of characters could be entirely different. The modern world often feels permanent when viewed through a human lifespan. Deep time offers another lesson. Familiar arrangements may rest upon events that could easily have unfolded another way. South America's lost world stands as a reminder that evolutionary history is shaped not only by adaptation and survival, but also by timing, geography, and chance meeting in a single moment of planetary history. Across the history of life, continents have sometimes drifted apart and remained separated long enough for evolution to begin speaking in distinct dialects. Given enough time, each isolated landmass becomes a workshop of invention. Familiar ecological challenges remain. Food must be found, predators must hunt, herbivores must evade pursuit, scavengers must locate carrion. Yet the creatures that emerge to meet those challenges often bear little resemblance to one another. South America's long isolation was one expression of this process. Its predators, grazers, and scavengers followed pathways found nowhere else. Looking beyond that continent reveals that the same experiment unfolded repeatedly across the planet. Each isolated region produced its own caste of animals, shaped by local history yet guided by recurring ecological demands. Australia provides one of the clearest examples. Separated from other major landmasses for roughly 45 million years, it developed communities dominated by marsupials. Species evolved to occupy roles that placental mammals filled elsewhere. The thylacine possessed a body form strikingly similar to a wolf. Thylacoleo became a powerful predator, often compared to a lion in ecological function. Marsupial moles tunneled through soil in ways that echoed the lives of placental moles on distant continents. These similarities emerged independently, shaped by comparable pressures acting on unrelated lineages. Far across the Indian Ocean, Madagascar followed another trajectory. Isolated from Africa for approximately 88 million years, the island nurtured animals found nowhere else. Giant lemurs moved through forests. Elephant birds grew into some of the largest birds ever known. Pygmy hippopotamuses occupied habitats unlike those of their larger relatives elsewhere. Each lineage represented a unique evolutionary story written during millions of years of separation. A pattern appears when these distant places are viewed together. Isolation encourages diversification. Lineages encounter opportunities unavailable elsewhere and branch into forms that would never arise in crowded continental ecosystems. The longer the separation persists, the more distinctive the resulting fauna becomes. Evolution explores possibilities that remain closed when constant interchange mixes populations and competitors across broad regions. Connection often changes that balance with surprising speed. When barriers disappear, organisms adapted within isolation suddenly encounter newcomers carrying different strategies, diseases, competitors, and ecological relationships. The process unfolds differently in every location, yet the fossil record frequently records elevated extinction among the endemic inhabitants. Madagascar's giant fauna declined rapidly after human arrival. South America's distinctive communities contracted after continental connection reshaped ecological networks. The details vary, though the broader pattern appears again and again. This recurring story reveals something important about evolution itself. The outcomes are never predictable in detail. No scientist could have foreseen terror birds, thylacines, elephant birds, or giant lemurs before they evolved. The specific creatures remain products of historical chance. Ecological roles, however, emerge with remarkable consistency. Open landscapes favor pursuit hunters. Vegetation supports grazers and browsers. Carrion attracts scavengers. Burrowing opportunities encourage subterranean specialists. Seen from that perspective, South America's terror birds, Australia's thylacine, and Madagascar's giant lemurs become parallel responses to enduring challenges. Different ancestors, different anatomies, and different continents produced distinct solutions. Life kept experimenting, adapting familiar ecological themes into new biological forms. Their histories linger as reminders that isolation can generate extraordinary diversity and that every separated world carries possibilities found nowhere else on Earth. A footprint pressed into mud can vanish within days. A mountain range may endure for millions of years before weather and tectonic motion reshape it. Entire ecosystems occupy a middle ground between those extremes, lasting long enough to seem permanent, yet remaining temporary when viewed across the full span of Earth's history. South America's island world belonged to that category, a biological realm that persisted for 60 million years before yielding to change. Its disappearance did not erase its significance. The rocks scattered across Argentina, Uruguay, Brazil, and neighboring regions preserve one of the most revealing evolutionary records ever uncovered. Within those layers, scientists found repeated demonstrations that life often arrives at similar solutions through different paths. Predators evolved where prey gathered. Swift runners emerged where open ground rewarded speed. Large herbivores appeared where vegetation could sustain them. Again and again, evolution worked with whatever ancestry happened to be available and produced forms that echoed patterns seen elsewhere across the planet. That lesson reshaped scientific thinking. Convergence came to be understood as more than a curious coincidence. Independent lineages, separated by oceans and millions of years, frequently arrived at comparable ecological roles. South America's history provided some of the clearest evidence. Its predators, herbivores, scavengers, and burrowers developed within isolation, yet many fulfilled functions recognizable from distant continents populated by entirely different groups of animals. The island also left living heirs. A Seriema stepping through grass carries traces of a lineage that once produced towering hunters. An armadillo moving across a roadside embankment belongs to a branch that survived continental isolation, ecological upheaval, and interchange. The opossum remains a traveler from a much older world, while the capybara descends from ancestors whose story reaches back to the rafting mammals that arrived during the island era. Each species represents a surviving thread woven through an immense span of time. Their continued presence invites reflection on a broader pattern visible throughout the history of life. Every ecological world eventually changes. Some are interrupted by impacts from space. Others are transformed by rising seas, shifting climates, volcanic activity, or drifting continents. Connections appear where barriers once stood. Barriers emerge where movement was once possible. No arrangement remains fixed forever. Even so, the history preserved in fossils reveals continuity within change. When one lineage fades, others expand into the opportunities left behind. After the non-avian dinosaurs disappeared, new predators rose. After the terror birds vanished, different hunters occupied the landscapes they once crossed. Ecological roles persist even as the creatures performing them change. Seen from the grasslands of Patagonia, that continuity becomes easier to imagine. The plains still extend toward distant horizons. Seasonal winds still move across them. Herds still travel. Predators still search. Scavengers still circle overhead. The actors have changed, yet the stage remains active. South America's island was neither a permanent kingdom nor a failed experiment. It was a chapter written across millions of years, rich with inventions found nowhere else. Its ending made room for another chapter, just as countless endings have done throughout Earth's history. Life continued forward, carrying fragments of the old world into the new, and the memory of the terror birds endures within that unbroken story.